So the most popular way of describing the beginning of the universe is the Big Bang Theory. So how do we prove the Big Bang Theory? How do we have proof that the universe existed with a Big Bang? Well, first we can look and observe the galaxies, the stars, are moving away from each other at a consistent pace. So galaxies are moving apart. And if we trace that movement apart back in time, about 3.8 billion years ago, everything in the universe will be at one singular point, the initial singularity. And the phrase Big Bang became a popular way of describing that initial bang of everything in the universe to expand out from each other without being collapsing in and itself because of gravity. So this initial Big Bang, it's just using the inversion of logic. Look at the galaxies moving apart. If we trace that back to their very beginning, it began in one singular point and then exploded out from there. But there's another really fascinating way of proving the Big Bang, proving what the universe was like early on. If you think about all of the matter in the universe being very close to each other, when things are close or dense, they get very hot. So there's a hotness and a density to the theory of the beginning of the universe, right? Think about going to a Taylor Swift concert. You're going to be super close to one another. You're dancing, you're singing, and you're producing heat. And it gets a little warm the closer you are to other people. And the further apart, it'll be less hot. If you look into space with a telescope, a very strong telescope, really, really, really far out, you can detect what the universe was like early on. That the light, the radiation from the beginning of the universe is finally reaching us. In that background radiation, that background light, very, very far away, is called cosmic microwave background. In other words, there's this background radiation of when the universe was very, very, very hot, very, very, very dense, that we can pick up using strong telescopes. And you don't see the light necessarily, but you can pick up the radiation readings from this cosmic microwave background from very, very far away. And even old televisions had this snow fuzz when you turn them on. That's picking up that cosmic microwave background, that background radiation that is existing really, really far out in the galaxy and finally, or in the universe, and finally reaching us. So this data from far away, using telescopes far away, shows what the universe was like a long time ago. And that shows or proves, adds data to prove the Big Bang Theory, how the universe was very, very close together 3.8 billion years ago, and very, very hot, very, very dense, before expanding out, cooling off, and collecting into forming galaxies and planets and stars, etc. My name is Jerry Dees. Never stop learning.